Okay, it says to solve the following differential equation by using integrating factors. So there they are. There's the well, yeah, what are integrating factors? Well, here we go. Here's the steps from the exam from the notes on the web page, the home page. Got to get derivative alone first, and then the y stuff and the other stuff that doesn't have y on the other side. So that's our step one. Let's do that. So step one. Let's we pretty much have it in that form, don't we? Yeah, it's already in that form. Got the derivative alone, got the y stuff, got the non-y stuff. We're good to go. All right. Step two, find the integrating factor mu of x, which is e to the integral of p of x dx, where the p of x is that stuff that's next to y. Okay. So what is it that's next to y? Well, there's just a 1 there, our p of x. Is just that one. The only thing next to y, there's nothing. It's a one multiplied by y, huh? So that means on step two, when we want to find our integrating factor mu, it's e to the integral of p of x dx, which is e to the integral of 1 dx, as p of x is just 1. And so what's that? That's just e to the x, right? Because the derivative of x will go back to 1, so the integral 1 is x, right? All right, so that's my integrating factor. Now, what do you do with it? Multiply in step three, the differential equation by mu of x. So all three terms get multiplied by that special integrating factor. So step three, I'm going to bring down my differential equation, but then I'm going to multiply this e to the x with all three. All right, and then step four, the left side is the derivative of the product of mu of x and y, the integrating factor in y. Write the left side as the derivative of those two things multiplied. Okay, so that's step number four. Let's do that. So I'm going to write the left side as the derivative, the d dx of y multiplied by my integrating factor, which was e to the x. And that's the left side, I mean. I see the right side, that's the left side. And then the right side stays the same. Now, you can double check it. You don't have to, but it's nice to see it. Is the derivative of this stuff really go back to these guys? Yeah, it does. A product rule, right? Two things multiplied. So derivative of the first, y prime, second one unchanged. First one unchanged, derivative of the second, e to the x doesn't do anything. So that's true. Okay, so now five, integrate both sides. You're starting to see the trick. So now on step five, I'm going to actually bring in an integral and an integral. And that's going to do some good stuff when I do that. That integral is going to make something nice happen. And of course, we plus a constant whenever we bring in a integral on both sides. Now, see what happens over here? Something really, really nice. The integral and the derivative cancel because they're opposites, right? Integrals and derivatives are opposites. So that just drops down the y e to the x unchanged. Here, I'll keep the same colors if that's helpful. No change at all. Okay, but on the right side, you got to do the integral. Why? Because it doesn't cancel out. We don't have a derivative and an integral, and those just cancel out. Here on the right side, we just have an integral. So we got to do the integral. Now, how to do the integral of 7x e to the x? Well, it's going to be by parts. Sorry, that X looks so bad. I got to fix it. We got to do by parts. When you see two things multiply like that, by parts. Now, let me show you. Here's a shortcut for by parts. There's the official by parts steps, but look, here's a nice shortcut. It's a shortcut method. All you got to do is take the first thing, x squared, or in our case, just x, and then the second thing. And then on the left side, you just take derivative of x squared, 2x, derivative again, 2, derivative, to get all the way down to 0. Take the derivative all the way down to 0. The other side, do the integral, integral, integral. Then put diagonal lines and put plus, minus, and that'll be your by parts integration. Let me show you. So it's quicker. Might look confusing at first, but it'll save you some time. So you just take the first thing, 7x, okay, and you go derivative. It's just 7. And derivative again. And that's 0, huh? right? Derivative of any constant number zero. So you could just go to your zero, and then you take the other side, e to the x, bring that down. This part was the 7x, okay? And then do the integral. Integrate it. What's integral of e to the x? Well, nothing. You'd say, I mean, same thing. And then integrate again, it just stays e to the x. It doesn't do anything. Okay, now, so what? Now connect these like that and like that. The diagonal line going down. And right on the first one, plus, and on the second one, minus. So there's more. We just keep going back and forth, plus, minus, plus, minus. That's going to be your integral. What do I mean? I'm saying it's going to be 7x times e to the x, and that's positive. And the next one's 7 times e to the x, and that's negative. Negative 7 e to the x. That's your biparts integral. Don't forget the plus c that's out there. Right, just right here, just bring that on down. And then the left side, we still have that as well. Y e to the x. In fact, let me just scoot it over because I want to do something. Okay, we good to there. Now we got to get y alone. So we did that. That was called the tabular method. This right here is a shortcut for biparts called the tabular method. You make a table. Again, what do you take? The first item, just derivative, derivative till it's zero. Take the second item, integral, integral. Then diagonal line, plus, minus, plus, minus. There we go. Anyway, so now we got to get y alone. Got to get rid of that e to the x. So what's going to do that for us? Well, I'm going to multiply through by e to the minus x. So those powers will add. E to the 0 is 1. That'll give me y alone. Whatever do to one part, do the other. E to the minus x, e to the minus x, e to the minus x. Right on through, right? These guys, powers add. 0. It's just 7x minus 7. These guys add. E to the 0 is 1. Gonzo plus c e to the minus x. So there we go. We got y alone. Now plug in what? What they tell us? Y of 0 is 35. That means if you put in 0 here, put in 0 here, y will be 35. So we get 35 equal 7 times 0 minus 7 plus c times e to the minus 0. And that's 35. 7 times 0 is 0 minus 7 plus c times 1. Because e to the 0 power is 1. Minus 0 is just 0. E to the 0 power is 1. So that means add the 7 over. So it's at 42 equals c to the 1. It's just c. C is 42. So we go, oh, okay. Go back to this equation, get rid of this, and pop in 42. And so there's how I'll rewrite it right here, maybe. So it's y equals 7x minus 7 plus 42 e to the minus x. So it's a terrible x. There we go. There's our equation. When we found the constant's 42. 7x minus 7 plus 42 is that what they got? Yeah, if you just show the 7x minus 7 plus 42, e to the minus x. Yep, they factored. You don't have to. So there we go.